April 26, 1986. The world's worst nuclear disaster had just occurred. Scientists at the Chernobyl nuclear power plant in Ukraine attempted an experiment. Their goal was to find a source of electricity to power the plant in the event of failure. Safety systems and cooling systems were disabled for this experiment. This proved fatal. An error led to a series of explosions that destroyed the reactor. 50 tons of radioactive nuclear fuel was disseminated across Eastern Europe. 45,000 people evacuated from their homes, not knowing why. The public backlash against nuclear energy was immense. What if this form of energy was too dangerous for mankind to harness? Could humanity control the incredible power of the atom? With advances to technology and mankind's ability to learn from the mistakes of the past, the clear answer to whether humanity could utilize nuclear energy is yes. Nuclear power plants, which harness the nuclear binding energy of a uranium atom, have many safeguards built into the design, and thus are safe. Therefore, we should continue to fund their implementation. Nuclear power plants produce power through nuclear power. Enriched uranium dioxide is shaped into small pellets, which are then rearranged into a long rod. This rod is the fuel for the reactor. These rods are then placed into a reactor, where, without interference, a nuclear reaction will take place. A nuclear reaction is a chain reaction. The nucleus, hence nuclear, of one atom, in this case uranium, is split. Because a nucleus consists of protons and neutrons, protons have a positive charge, and neutrons have a negative charge. Energy is required to hold the nucleus together to counter the repelling of the positive charges. Uranium-235 is an unstable isotope used in the reaction. A free-moving neutron is introduced in the complex of uranium atoms, where the neutron is captured by the uranium-235 nucleus. Because uranium-235 is highly unstable, the introduction of the neutron splits the atom, releasing the nuclear binding energy of the nucleus in the form of kinetic and heat energy, also releasing 2 additional neutrons, which travel 1/15th the speed of light. These high-energy neutrons then strike additional uranium atoms, slowing the neutron down and splitting these uranium atoms. Thus, if one was to divide the neutron colliding with the nucleus of a uranium atom into stages, one can see, from one stage to the next, the number of neutrons that are available to split an atom is the square of the number of neutrons in the previous stage. Very quickly, the number of atoms split increase, and the amount of energy in the form of heat and kinetic released grow very quickly. A tremendous amount of heat is then released. A nuclear reactor harnesses the heat released in this reaction. There are 2 main types of reactor, the boiling water reactor and the pressurized water reactor. In a boiling water reactor, the core sits inside a pressure chamber filled with water. Heat from the core boils the water, which turns into steam. Pressure from the chamber gives the steam a high kinetic energy, which runs through pipes to another chamber, turning a turbine, which, through electromagnetism, creates electricity. The steam in the turbine building is cooled, which, through pipes, run back into the pressure chamber to be reused. The pressurized water reactor is similar in the way that boiled water acts as the driving force to turn the turbine. Instead of a single chamber, however, there are 2 chambers. One chamber containing the core and the steam generating chamber, which contains water to be boiled. A closed loop of water runs between the 2 chambers. Heat from the core is absorbed by water in the loop, which then transfers heat to water in the steam generating chamber. The water boils, turning a turbine, producing electricity through electromagnetism. Hiroshima, Nagasaki. Cities leveled by the awesome power of the atom, and now, instead of using the power to destroy, this technology is being used to create. Lights, computers. The 21st century world needs electricity to function, and this electricity is created with the same power used to level a city. How safe is nuclear energy? Why do we even need nuclear energy? Why not an alternative form, like wind? It's safer and green, right? According to James Conca, a nuclear expert of Forbes.com, nuclear energy is one of the safest forms of energy. Nuclear energy has a death rate of 90 people per trillion kilowatt hour of electricity produced. a rate, so how prevalent each form of energy is around the world happens to be irrelevant in this statistic. This is low, compared with other forms of green energy, such as hydro, with a global average of 1,400 deaths per trillion kilowatt hour, or solar, which has an average of 440 deaths per trillion kilowatt hour, and wind at 150 deaths per trillion kilowatt hour. Statistically, nuclear energy is the safest form of energy. This is due to the various safety mechanisms built in place to prevent a disaster on the scale of Chernobyl from happening again. To begin, control rods are made of neutron-absorbing material, which, because neutrons are the catalyst for a nuclear reaction, by absorbing neutrons, the reaction is slowed and could be stopped. There is a wide variety of material that can do this. The reactor at the Massachusetts Institute of Technology is controlled with material made up of boron and stainless steel. There are 4 primary layers of safety to prevent radiation release in the event of a nuclear catastrophe, which the control rods seek to prevent. The first layer is the fuel matrix. Uranium dioxide has a high melting point at 2,760 degrees Celsius. Although large amounts of radioactivity occur in the fuel rods, 98% of the radioactivity is retained by the fuel. If the fuel does not melt, thus the radioactivity is not released into the environment, the scale of the catastrophe is reduced drastically. The second layer is the zircaloy clad, which surrounds the fuel rods, which retains any radioactivity leaked from the uranium. The third layer is a primary coolant system. A thick steel container surrounds the reactor and piping can be up to 8 inches thick. This is to ensure no radioactivity can escape the reactor. It is law that the design of the power plant must accommodate for the failure and rupture of the coolant pipes. It is crucial the temperature of the reactor is kept under control, and these safety mechanisms ensure the reactor can be cooled in the event of a failure of the primary cooling system. The final layer is the reactor containment building. Driving by a nuclear power plant, this is the giant dome that one may see. The concrete containment is generally 4 feet thick, lined with steel, and reinforced with steel bars. The steel strengthens the structure, withstanding any forces, internal or external, in the event of a catastrophe. In our day and age, climate change is the biggest problem that humanity is facing. It is evident that the burning of fossil fuels is one factor contributing to the buildup of carbon dioxide, a greenhouse gas in the atmosphere, which contributes to climate change. Carbon dioxide concentration has increased by more than a third since the Industrial Revolution, where many early power plants that burned fuel emerged. Such effects from this problem cannot be mitigated. Sea levels will rise due to melting ice caps, flooding many coastal cities, forcing people to move inland. Crop failures in many parts of the world, because plants cannot adjust to the new climate, will lead to famine. Animals will become extinct due to habitat loss because of climate change. It is undeniable climate change is a serious problem, and humanity must face it. One such way to combat climate change is through green forms of energy that do not harm the environment. This will reduce CO2 emissions, thus reducing the impact of climate change. Nuclear power is an ideal form of energy because while uranium is not renewable, 1 ton of uranium can produce more energy than 16,000 tons of coal or 80,000 barrels of oil. The amount of energy that can be harnessed from uranium is incredible. Furthermore, while fossil fuel plants release carbon dioxide into the atmosphere, nuclear power plants release water vapor, which do not contribute to climate change. There is much more energy to be harnessed from the atom than there is harnessed from fossil fuels, and nuclear energy is cleaner than fossil fuels. Therefore, we should continue to fund nuclear power plants. While nuclear power plants are perceived by many as dangerous and unstable, it is hardly so, and statistics show that nuclear is the safest form of energy available for mankind. Advanced safety mechanisms built into the structure of the power plant prevent catastrophe, and the event of a catastrophe mitigates the impact of the catastrophe on the environment. Furthermore, nuclear is a green form of energy, and it is undeniable that humanity must combat the problem of climate change. Society needs to move away from the dirty, polluting, CO2-emitting fossil fuels and towards greener, cleaner forms of energy, with nuclear being the safest form of energy available in the 21st century.